Have you ever wished you could hold your ideas in your hand, transforming the intangible into something real? Imagine taking a concept from your mind and giving it physical form. That's the magic of 3D printing, a revolutionary technology that's reshaping how we create and innovate. It transforms digital designs, those lines of code and virtual shapes, into real physical objects that you can touch, feel, and use. Layer by layer, a process known as additive manufacturing. Instead of carving away material like traditional machining does, creating waste in the process, 3D printing adds it exactly where it's needed, building up the object from the ground up. This allows for the creation of complex shapes with minimal waste, opening up possibilities that were previously impossible. This technology, once reserved for factories and large-scale industrial applications, is now accessible to anyone with a creative spark, bringing the power of manufacturing to your fingertips. You can print a custom part, perfectly tailored to your needs, a piece of art, expressing your unique vision, or a replacement for something broken, extending the life of your belongings, all from your desktop, empowering you to become a creator and problem solver. The process is simple. Start with a blank plate, a clean slate ready for creation, and the printer builds your object, slowly but surely bringing your design to life, fusing each new layer to the last, creating a strong and cohesive final product. It's a patient, precise dance of mechanics and heat, a symphony of engineering working in harmony. The only real limit is your imagination, so dream big and let your creativity soar, and your ability to design, which is a skill that can be learned and honed with practice. But how does a printer turn a digital file, a set of instructions, into something you can hold? Let's pull back the curtain and peek inside and explore the mechanics behind this modern magic, uncovering the secrets of 3D printing. Get ready to dive into the world of 3D printing and discover the endless possibilities it offers. Let's break down the key components that make up a typical 3D printer and understand how each part contributes to the printing process. We'll explore the function of each of these components and how they work together to bring your digital designs to life. The extruder is the star of the show. It's responsible for feeding in plastic filament, the raw material for your prints. It then melts it at a precisely controlled temperature and lays it down with pinpoint accuracy, following the instructions from your digital model. The build plate is the stage where the magic happens. It's often heated to help prints stick firmly and prevent warping, ensuring a stable foundation for your creations. Stepper motors are the workhorses that move the extruder and plate. They control the movement along the X, Y, and Z axes with incredible precision. They are following digital instructions sent by the mainboard. The frame is the skeleton that keeps everything stable and aligned. It's crucial for ensuring smooth, precise movement of all components. The mainboard is the brain of the operation. It's responsible for reading your design file and sending precise commands to every part of the printer. Each component works in perfect harmony, building your object one layer at a time with incredible accuracy. A rigid frame translates to crisp, detailed prints, but a wobbly one can lead to all sorts of trouble, like misaligned layers and poor print quality. The mainboard interprets your design with precision, controlling the motors and heaters with split-second timing to ensure a flawless print. It's a mechanical orchestra, with each part playing its role perfectly. It's turning lines of code into tangible reality right before your eyes. With all of these parts working together in perfect synchronization, your ideas can finally take shape, transforming from a digital concept to a physical object. Now let's dive deeper and see how a print actually happens, step by step. Here's how a 3D print comes to life. The printer heats up the nozzle and build plate to the right temperatures. It homes its axes, finding the exact starting point. The mainboard reads the first command and the extruder begins tracing the first layer onto the plate. After each layer, the Z-axis lifts the nozzle by a fraction of a millimeter. The process repeats: move, extrude, lift, hundreds or thousands of times. Layer by layer, your object grows from the plate. The mainboard keeps everything in sync, adjusting speeds and temperatures as needed. Prints can take an hour or days, but patience pays off. Soon, your digital idea becomes a physical reality. Every print starts with a digital model. You can design your own using CAD software, sculpt in Blender, scan real objects, or download models online. Most designs are saved as STL files, a universal format describing the object's shape. But the printer can't read STL files directly. That's where Slicer software comes in. The slicer takes your model and slices it into thin layers, planning the path for the extruder. You control settings like layer height, print speed, and infill. The slicer then generates G-code, a script of step-by-step instructions for the printer. G-code tells the printer exactly where to move and how much filament to use. With your file ready, you're set to print. Next, let's see how slicing and settings affect your final object. Let's dive into the practical side of things and get hands-on with slicing. We're going to walk through a real-world example to illustrate how these settings come together. Imagine you want to print a hollow cube. This is a common project, great for learning the basics. The first step is to load the STL file into your slicer software. This is the digital blueprint of your cube. Next, set a standard layer height, something like 0.2 mm is a good starting point. This setting determines the resolution of your print, striking a balance of speed and quality. Smaller layer heights mean finer details but longer print times. Now, let's talk infill. Choose an infill density, maybe 15% with a grid pattern, to save on material and reduce printing time. The infill provides internal support without making the print solid. The slicer then meticulously plans the path for the outer walls and calculates the internal support pattern, ensuring structural integrity. When dealing with tricky overhangs like the top of a T-shape, the slicer intelligently adds temporary support structures. These supports are essential for preventing sagging and ensuring a clean print, and you'll remove them after printing. Remember, orientation matters. For example, print a bolt on its side to maximize its strength along the shear plane, while you might print a nut flat to capture fine thread detail. Using slower print speeds is crucial to accurately capture those fine details, especially when printing threads. By carefully adjusting the orientation, infill density and support structures, you have precise control over the strength and overall quality of your print even before it begins. Slicing is truly where engineering principles meet creative design. Every single setting you tweak has a direct impact, shaping the final result in subtle but significant ways. By making the right choices and understanding their effects, you're setting your print up for success from the very start. Now, with all these considerations in mind, let's bring it all together and watch the magic happen. From idea to object, 3D printing is a journey of transformation. It starts with a digital model, sliced into instructions the printer can follow. The printer heats, moves, and deposits plastic, building your design layer by layer. Supports and infill add strength and structure. Each component, from the frame to the nozzle, plays a vital role. When the print finishes, you remove it from the plate, snap off supports, and hold your creation. You've turned data into something real. 3D printing fuses the digital and physical, empowering anyone to invent and create. The process is precise, patient, and endlessly rewarding. That's the magic of 3D printing, bringing your ideas to life.